Section 9.5, Example 3, Merging Phone Picture Libraries. Now suppose that you take a lot of pictures on your phone. Your partner, or sibling, parent, or child, also takes a lot of pictures on their phone. You each have hundreds or thousands of pictures. Sometimes you send pictures to your partner, and they send pictures to you, so that you and your partner have some but not all of each other's pictures. You live life like this for a while, but honestly, it's becoming a mess. Half the time when you want a picture, you can't find it because it's a picture that your partner took on their phone that they didn't send you, and you're starting to have many duplicate pictures all over the place. You then have an idea. What if we take all the pictures from my phone and all the pictures from your phone, and we create a combined library of all the pictures? Then we'll have all the pictures in one place. Remember that both of your phones may have hundreds of pictures, so doing this manually is out of the question. We're going to automate this. To specify our task more precisely, we'll say that we have two directories of pictures. Think of each directory as the contents of a phone, that we want to combine into a new directory. A common file format for pictures is a PNG file, so we'll work with those files here. Your actual phone might use JPG files rather than PNG files, but don't worry. You can adapt what we do here to that picture file format, or any other picture file format, if you like. In the resources for this book, in the CH9 directory, you'll find two subdirectories of picture files. These subdirectories are named Pictures 1 and Pictures 2. You can imagine that Pictures 1 has the pictures from your phone, 98 pictures, and Pictures 2 has the pictures from your partner's phone, 112 pictures. We're going to combine these two phone directories into a new directory. Open some of the PNG files in the same way that you open pictures or photos on your computer. The pictures we've generated are just some random shapes, but the program we write here will work no matter what's inside the pictures. At the outset, we said that the same picture might be on both phones, so we've generated some duplicate files in our pictures. We have a total of 210 picture files, but 10 of them are duplicates, so there are only 200 unique pictures. For example, in the Pictures 1 directory, there's a file called 1566.png, and in the Pictures 2 directory, there's a file called 2471.png. These two files are identical, and when we generate our directory of files from both phones, we'll only want to keep one of these. What's tricky here is that these pictures are the same, even though their file names are not. What if two file names are the same? Does that mean that the pictures are the same? For example, notice that each directory, Pictures 1 and Pictures 2, has a file called 9595.png. You might think that file names being the same means that the pictures inside will be the same too. But no, if you open these pictures, you'll see that they're different. This could happen in real life too. You and your partner could both take different pictures, and however remote, it's possible that the file names your phones choose for those pictures just happen to be the same. If we're not careful, we'll end up copying 9595.png from Pictures 1 into our new directory, and then overwriting it later by copying 9595.png from Pictures 2 into our new directory. We need to be sure that when we copy a file, we're not overwriting a different picture that may already be there with the same file name. We provide an example of this process in Figure 9.3.
Figure 9.3. Example of merging the photos in the Pictures 1 and Pictures 2 folders into the Pictures Combined folder and managing the removal of duplicates.
We're working with directories, not actual phones. We're assuming here that you have two directories of pictures already on your computer. These directories could have come from anywhere, and nothing we do here has anything specific to do with cell phones. But if you wanted to do this task for real with pictures on your phones, you'd need to get those pictures onto your computer first. You could use ChatGPT to have that discussion. As the details are specific to different phones and go beyond what we want to use Copilot to automate, we won't go further into this here. Section 9.5.1, Conversing with Copilot. Our tool is going to create a combined directory of pictures from Pictures 1 and Pictures 2, but without duplicate pictures. If our combined original picture directories have the same picture multiple times, we want only one of those copies of the picture to survive in our new directory. At this point, there are at least two things we might like to know. How do we copy a file using Python, and how do we know whether two files are the same picture? Let's start by asking Copilot Chat how we can copy a file. Human: I need to write a Python program that copies files. How do I do this? GitHub Copilot. You can use the SHUtil module in Python to copy files. Here's an example.
See this code?
This will copy the file from the source path to the destination path. If the destination file already exists, it will be overwritten. Excellent. We can use that SHUtil module to copy a file. We'll need to remember to import that module. The final sentence that Copilot gave us is an important warning. We should be careful to avoid copying a file over the top of another file that already exists. Next, let's determine whether this SHUtil module is built into Python. Human. Is this SHUtil module built into Python? GitHub Copilot. Yes, the SHUtil module is a built-in module in Python, so you don't need to install anything extra to use it. You might wonder why we're focusing on making copies of files and putting them into our new directory, rather than moving them from our original directories into the new directory. The reason is that we want to leave our original directories alone just in case we have a bug and fail to get all the files into our new directory. If anything goes wrong in our new directory, it won't matter because our original directories will still be intact. That wraps up what we need to know about copying files. Now let's move on to learn how we can determine whether two files are the same picture. As we've already said, it's not sufficient to use file names to determine whether pictures are the same. How can we do it then? Human. Using Python, how can I determine whether PNG files are the same? GitHub Copilot. You can use the file CMP module in Python to compare two files and check if they are the same. Here's an example code snippet that compares two PNG files.
See this code?
This code will compare the contents of the two files and return true if they are the same, and false if they are different. As a quick aside, the last sentence from Copilot is wrong. That code isn't returning true or false anywhere. Just like Copilot can generate faulty code for us in our Python file, Copilot Chat can produce faulty explanations. Our prompt wasn't precise about the number of files that we need to compare. Do we want to compare two files? Hundreds of files? Our prompt doesn't say. Copilot has told us what to do if we want to compare two files, which is a reasonable thing to tell us. But that's not quite what we need. We need to be able to determine, among hundreds of files, which files are duplicates of other files. That way, we can detect a duplicate file and not copy it into our new directory. Let's try again. Human. What if I have hundreds of PNG files and I want to find duplicates? Is that approach you gave me still good? GitHub Copilot. If you have hundreds of PNG files and you want to find duplicates, you can use the OS module to iterate over all the files in a directory and compare each file to every other file in the directory. Here's an example code snippet that does that.
See this code?
This code will iterate over all the files in the directory and compare each PNG file to every other PNG file in the directory. If two files are the same, it will print a message indicating that they are duplicates. Note that this approach can be slow for large directories with many files. The outer for loop goes through each file in the directory. How do we know whether the current file has a duplicate? Well, we can go through each other file in the directory and compare it to the current file. That's the role of the inner for loop. It uses file cmp.cmp to compare the current file, file 1, to each other file, file 2. We didn't mention in our prompt that we care about finding duplicates across multiple directories, so Copilot has focused on a single directory here. If that difference turns out to be a roadblock, we could make our prompt more precise. Copilot is using two other modules here, OS and file CMP. We could ask Copilot if these are built-in Python modules or not, but we'll save a little time and just tell you here that they are built-in. We now want you to focus on the final sentence from Copilot. Note that this approach can be slow for large directories with many files. How slow is slow? How many is many? We don't know. You might be tempted to ask Copilot for a better solution, one that isn't slow for large directories with many files. But many programmers wouldn't do that. It's often a mistake to optimize our solution before we have even tried out our unoptimized, apparently slow, approach for two reasons. First, maybe our slow program turns out to be fast enough. We may as well try it. Second, more optimized programs are often more sophisticated programs, and they may be more difficult for us to get right. That isn't always the case, but it can be. And again, if our unoptimized program gets the job done, we don't even have to worry about a more optimized version at all. Now, if it turns out that our program really is too slow or you find yourself using the program repeatedly, then it may be worth the extra investment in continuing to work with Copilot on a faster solution. For now, though, we're good. Section 9.5.2, Top-Down Design. There's a little more going on in this task than in our prior two tasks. For one, we need to be careful not to overwrite a file that already exists in our new directory. For another, we need to determine which files to copy in the first place. Remember that we only want to copy files that don't already match a file in our new directory. Compare this to the PDF merging task we just accomplished, where we didn't have these extra concerns. To that end, we're going to use top-down design and problem decomposition here. Don't worry, it won't be a full-on top-down design example like we did in Chapter 7. Our task here is much smaller than our spelling suggestions task from that chapter. We'll just do a little top-down design, and that will help Copilot get us what we want. Our top-level function will be responsible for solving our overall task, taking the Pictures 1 and Pictures 2 directories and putting all unique pictures into a target directory. Back in Chapter 3, we learned that we should make functions as general as we can to make them more useful or generalizable to other tasks. Here, we've been thinking about combining 2 picture directories together, but why not 3, 5, or 50 directories? Who cares how many directories we have? We should be able to just combine as many directories as we want. So, instead of designing our top-level function to take 2 strings, directory names, as parameters, we'll have the function take a list of strings. That way we can use it on as many picture directories as we want, and we can still readily use it on 2 picture directories. We'll just pass a list containing the names of the 2 directories. We'll name our top-level function makeCopies. We'll need 2 parameters, the list of directory names that we just discussed, and the name of our target directory where we want all the files to go. What's this function going to do? It's going to loop through each directory in the list of directories, and then, for each directory, it's going to loop through each file. For each file, we need to determine whether to copy it or not, and, if we need to copy it, to do the actual copying. Determining whether to copy the file, and then possibly copying it, is a subtask that we can split out of makeCopies. We'll name our function for this subtask makeCopy. Our makeCopy function will take 2 parameters, the name of a file and the target directory. If the file isn't identical to any file in the target directory, then the function will copy the file into the target directory. Say we want to copy a file called 9595.png from one of our picture directories into our target directory, but that file already exists in the target directory. We don't want to overwrite the file that's already there, so we'll need to come up with a new file name. We might try adding an underscore character prior to the PNG part of the file name. That would give us 9595_.png. That one probably wouldn't exist in the target directory, but if it did, we could then try 9595_.png, 9595_.png, and so on, until we find a file name that doesn't already exist in there. Generating a unique file name is a task that we can split out of our makeCopy function. We'll call it getGoodFileName. It will take a file name as a parameter and return a version of that file name that doesn't already exist. And with that, our top-down design is done. Figure 9.4 depicts our work as a tree. Well, at least the trunk of a tree, showing which function is called by which other function.
Figure 9.4. Top-down design for image merging. The topmost, leftmost function is makeCopies. The child of that is makeCopy, and the child of that is getGoodFileName.
Section 9.5.3. Writing the tool. We don't have any modules to install this time around. We do know from our Copilot conversation that we'll use the built-in SHUtil module to copy files. We'll also use the built-in FileCMP module to compare files and the built-in OS module to get a list of the files in a directory. We'll therefore import these 3 modules at the top of our Python program. As in Chapter 7, we're going to solve our problem by starting at the bottom of our function tree and working toward the top. We do that so Copilot can call our already written functions when writing code for a parent function. For each function, we provide the def line and docstring, and Copilot writes the code. We've also provided some annotations to explain how the code works. Looking again at Figure 9.4, we see that the first function we need to implement is getGoodFileName. Let's get that one done now in the following listing.
Listing 9.6. GetGoodFileName function for our picture merge task.
The next function we need to write is makeCopy. This is the function that copies a file into a target directory, but only if the file isn't identical to a file that we've already copied. We're looking for Copilot to do several things in its code here. Use os.listdir to get a list of files in the target directory. Use file cmp.cmp to determine whether two files are identical. Use shutil.copy to copy the file if there was no identical file. Call the function getGoodFileName that we just wrote. The following listing shows our prompt and the code that Copilot provided. Notice that the code is doing everything that we wanted it to do.
Listing 9.7, make copy function for our pictures merge task.
There's only one function to go, and it's our top-level makeCopies function. For each file in each of our picture directories, we're expecting the code to call makeCopy to copy the file if needed, as shown in the following listing.
Listing 9.8, make copies function for our picture merge task.
The final line of code from Copilot beneath the makeCopies function makes the assumption that our target directory will be named pictures_combined. Create that directory now so that it sits alongside your Pictures1 and Pictures2 directories of pictures. As we discussed when working with PDF files earlier in the chapter, it's important that you first test the program on sample directories that you don't care about. Your sample directories should have only a few files in them, so that you can manually determine whether the program is working as expected. You should also include important edge cases, such as having the same file name in each directory. Once you have your sample directories, you should create a harmless version of the program that simply outputs messages rather than actually copying files. For our program here, you would change the line in makeCopy to use print rather than shutil.copy. If the output looks good after you check the results carefully, only then should you run the real program on your real directories. Remember that our program is copying, rather than moving, files, so even in our real directories, if something goes wrong, there's a good chance that the problem will be in our new directory, and not the original directories that we actually care about. We'll assume that you're now ready to run the program on the Pictures1 and Pictures2 directories. Once you run it, you can check your pictures_combined directory for the results. You should see that the directory has 200 files, which is exactly the number of unique pictures that we had across our two picture directories. Did we correctly handle the situation where the same file name existed in both picture directories, but were different pictures? Yes, you can see that we have files named 9595.png and 9595_.png, and that we therefore haven't overwritten one with the other. Oh, and how long did the program take to run on your computer? At most a few seconds, right? It turns out that Copilot's warning that this approach can be slow for large directories with many files didn't matter for us. Now, we all know that people tend to have thousands of pictures on their phones, not hundreds. If you ran this program on two real phone picture libraries, you would again need to determine whether it completes in an acceptable amount of time. You could run the program and let it run for a minute or two, or however long you're willing to wait. For fun, we also tested our program on a total of 10,000 small image files, a more realistic scenario than the 210 pictures across our Pictures1 and Pictures2 directories that we used in this chapter, and we found that it only took 1 minute to complete. At some point, our program will become too slow to be practical, and that's when you'd need to do further research with Copilot Chat to arrive at a more efficient program. In this chapter, we succeeded in automating 3 tedious tasks: cleaning up an email, adding covers to hundreds of PDF files, and wrangling multiple picture libraries into one. The approach in each case was the same. Use Copilot Chat to determine which module or modules to use, then follow the approach that we've honed throughout the book to have Copilot write the required code. Remember, whenever you find yourself repeating the same task, it's worth trying to automate it using Copilot and Python. There are many helpful Python modules for doing so, beyond what we showed in this chapter. For example, there are modules to manipulate images, work with Microsoft Excel or Microsoft Word files, send email, scrape data from websites, and more. If it's a tedious task, chances are that someone has made a Python module to help with it and that Copilot will be able to help you use that module effectively.